Okay, hello everyone. So today this is the lecture 5 of unit 4. So this will be the last concept. So we shall see today the applications of double and triple integrals, right? So as we have already solved the problems of double and triple integrals, so which is also useful in solving some practical problems or well-known problems, right? So let us see what is this area. So in the double integral, so given a region or the area of any given function which contains variables x and y with respect to dx dy, okay, if f of xy is equal to 1, then the given area is dx dy is given area under the region, right? Now let us find now let us find the area. So let me have the problem. So first problem is find the area by double integration between the parabola, that is y is equal to 4x minus x square and y is equal to x, right? So what I'll do is first I will write the given equation, that is y is equal to 4x 4x minus x square. Let me consider this as equation 1, and y is equal to x. Now if I take y is equal to x over here, so y is equal to x, so definitely it is a straight line passing through the origin, that is at 45 degrees, right? Okay, so one of the sketch and when you plot this, that is y is equal to 4x minus x square, it is a parabola opening towards upwards, right? Now if you take this x and substitute over here, so it turns out to be, that is x is equal to, that is 4x minus x square, which I have written here, right? And then it is a quadratic equation, so you have two roots, that is x equal to 0 and x equal to 3. Now when x equal to 0, then y is equal to 0. When x equal to 0, then y is equal to 0. When x equal to 3, then y is equal to 3. Therefore the point of intersection over here is, that is 3 comma 3, right? Now the area is given by the given area, or the required area is equal to, that is a over some part. Okay, now this sum part is nothing but your dy dx. Now either you can take vertical strip or horizontal strip. Now in this case I have taken, that is horizontal strip, like this from x, right? In this direction I have taken, that is horizontal strip. Therefore what is this curve? This curve is, in fact, what is this point on this curve? This is here, from here to here. So this is y is equal to x. So x to this curve is what? It is y is equal to this equation 4x square, 4x minus x square, right? So this is, if you're moving from this position to this, so it is x is equal to, that is x, that is 4x minus x square, right? So it is 4x, sorry, so this equation is y is equal to 4x minus x square, right? So what I'll do is, so it is x is equal to 4x minus x square, and what is the value from here to here? That is, it is from 0 to 1, fine. And then what is the value of that is y? So y is ranging from, that is 0 to 3. Here I have to write 3, so this is not 1, it is 3. Okay, so it is 0 to 3. Therefore as usual, so this is I need to integrate this. So integrate, that is 0 to 3, that is, it is integration of 1, it is with respect to y first, because this is y is equal to, so first pattern what I am going to take, that is dy first. So I am taking dy first. So integration of y over limit, that is x to 4x minus x square dx. Then over the integral 0 to 3. So if I substitute this turns out to be 4x minus x square minus x, right? So it turns out to be 3x minus x square dx. Now after integrating this over the limit 0 to 3, finally you get this answer as 9 by 2. Fine. Okay, let us move on to the next problem. So find the area of the loop, they have said, right, of the curve, that is a square x square which is equal to y cube, that is 2a minus y, right? So the given curve, when you plot this graph, first thing is you should always have an idea of having a rough sketch. My writing pad is not working, so kindly again bear me, as I said in earlier classes also. Okay, so since the curve is symmetric about y-axis, right, so there are certain properties. There's a concept known as tracing of curves, wherein you can say, depending upon when you draw a rough sketch, whether the given curve is symmetric about y-axis, whether the given curve is symmetric about x-axis, or whether the given curve is symmetric about the pole. In the sense, suppose it depends upon, suppose y is equal to 4, y square is equal to 4ax, right? Now it depends whether the power of y is even or odd, or the power of x is even or odd, or at any instant if the value, after substituting certain values for y, suppose I will take y is equal to x. If x is 0, then definitely value of y will be 0. If x is and in the same case, if y is 0, then definitely the value of x is 0. If you interchange these two values, okay, and at any instant if value of x is 90 degrees, then value of y will be 90 degrees, and if value of y is 90 degrees, then value of x will be 90 degrees. So therefore it will be what, the given curve will be symmetric about the pole. Now this is one of the example. So this, see here, if you fold this paper from about y-axis, so it will be symmetric over this, and if you fold horizontally, again it will be symmetric, right? So here when you plot the graph, that is if I take, that is x square is equal to, that is y cube in the bracket 2a minus y, okay, divided by, and that is a square, okay, and then if I take this square over here, fine, okay. Now what you do is, see here, if I substitute, and then I am taking in terms of x, okay, or you can take in terms of y also, right? If I substitute y is equal to 0 first, okay, see here only for y cube, if I am substituting 0, obviously this whole term turns out to be 0. So for the value, that is x comma 0 comma 0 it is. Now see here it is 2a, right? Here it is 2a. Then for the value of what will be the maximum value I can take, right? So here it is square root sign. I do not want an imaginary number. So y, if I take y is equal to, that is if I take y is equal to 2a, right? Again this turns out to be 0. Therefore the value of x will be 0, and that is the reason if you take value of 2a, here it will be 0. But for other values of x, if you are taking, so it will be obviously this particular loop. Now by this geometry, and as I said, depending upon the power of y, or whether it is even or in a given function, here the power of x is positive, and the power of y is that is it is that is y square, yet it turns out to be even, right? And here it is now if I substitute the value of y as 2a, that is the maximum value, x turns out to be 0, right? So this is the rough sketch of the given equation. So you can try. Fine. Okay, now since the curve is symmetrical about y-axis, okay, So required area is, see here, I will not include this area because it is already symmetric. So this is first part of the region, and this is the second part which is symmetric. So I will not include the whole of the loop. So I will take one part of the loop and take horizontal strip. Now integrate along horizontal strip from this side to this side. Okay, fine, over this curve. Now this curve is nothing but, so x varies from, what is the value of x? X is 0, right? And what to what? So in terms of x I will take, so this is y is equal to okay, fine. So x varies from 0 to y divided by a. So this particular equation, right here, so this will be, that is y divided by a, because I am taking square root sign. So here this square root sign, y square into y it is, right? If I am splitting this y cube in terms of, that is y square divided by y. So here this will turn out to be, if I am taking square, this turns out to be y, and then y and y again it will be, that is, it turns out to be y square. Okay, so here it is y by a into y divided by net. Okay, so this y divided by a, because y square it turns out to be y, and this square root sign will go inside, so it is square root of y 2a minus y, right? And y varies from what? So y varies from 0 to 2a, this, right? 0 to 2a. Therefore the required area is twice, that is 0 to 2a and 0 to y by a, square root of y in the bracket 2a minus y dx dy, right? So the function is not given, you have with the help of this rough sketch you have taken the limiting points. Okay, now since this is in terms of y is equal to, so y is equal to x, right? Sorry, it is I take my words back, it is x, no, x in terms of y. Yes, so it is in terms of, that is x is equal to 0, and this is x is equal to, because x is expressed in terms of y. So first thing is I will integrate it with respect to x, that is dx. Therefore it is x 0 to y by a, square root of y in the bracket 2a minus y. Now if I substitute this upper limit, it turns out to be y. This a I am taking outside, and square root of y 2a minus y dy. Now this, if I substitute 0, so I do not substitute it. Now to make this much more simple, right? So what I do, I substitute y is equal to 2 a sine square theta. Okay, and since when I'm substituting it and then differentiating it with respect to theta, so this is dy by d theta, or dy is equal to 4a, that is sine theta cos theta into d theta, right? So differentiation, and then even I need to change this limit. So what is happening to this limit? So if y is 0, then theta is equal to 0, and if y is when y is equal to, that is 2a, then what is happening to theta? It is pi by 2. See here, if I substitute 0 over here, so therefore definitely what is the value of, that is theta? So sin 0 is 0. And see here, if I substitute y is equal to 2a, this 2a gets cancelled, here it is 1. So what is the value of theta? Theta is equal to, that is pi by 2. Now here when I am taking this particular value, so see here, so I will keep the things as it is. This y I will write here, fine. Okay, and this under square root sign, this y I am writing here, sorry, here, and this is 2a, here it is. Okay, and then again y, here it is 2a sine square theta, fine. And this dy is this particular value, and this dy is nothing, this whole term, right? Fine. Okay, now also I am changing the limit, that is here it is 0 to 2a, then it turns out to be 0 to pi by 2, right? Now this is 2a sine square theta, 2a sine square theta, I will take 2a common outside from here. This turns out to be 1 minus sine square theta, and 4a sine theta cos theta d theta. Now this a and this a gets cancelled, so it is, see here, it is 4a square and sine square theta. What is 1 minus sine square theta? It is cos square theta. And 4a sine theta cos theta. So what I'll do is, this is square root sine 4, it becomes 2a square, it becomes a, sine square theta, it becomes sine theta, and this becomes cos theta. So sine square theta, this one square, this is 2 by laws of indices plus 1 and plus 1 more here, right? So total there are, that is, it becomes sine square, this is 1, okay, here it is 1 and here it is one more value, right? So this is, so here the value it turns out to be, that is, it is equal to, that is 4. Here I need to write 4. Sine power 4 theta, and this is cos square, that is this cos and this cos, it turns out to be cos square theta d theta. Now this 2 I am writing here 2 into 2, and this 2a here, this particular thing, okay, and this 4a, right? All the constant I am taking outside, it turns out to be 32a square. Then I have given a formula, if the integral is of the type, that is 0 to pi by 2 sine m theta cos n theta d theta, that is in the reduction formula. So after taking the reduction formula and evaluating it, so this is with respect to m, this is with respect to n, this is n or this is m or nm, whatever is the value you are taking, right? So after evaluating, you get the answer, that is pi a square. Here it is 4, please make correction. Yes. Now let us move on to the next problem, and the next problem is, okay, see here, this is what I was telling you about on the other day, about find the area of Lemniscate Bernoulli. The curve r square is equal to a square cos 2 theta, right? Okay, so this was the graph, and find the area of Lemniscate Bernoulli, the curve, that is r square. This is a standard curve, and you need to find the area. Last time it was only one loop. If you turn up your pages or the video lecture, so it was the given problem was only for one loop, okay. Since the curve is symmetric about the pole, right? So if you fold this paper from top to bottom or bottom to top, like either you take it vertically or horizontally, so the loop will be the same, right? So it will be symmetric about the pole. Now the required area is 4 times the area of the above line, that is theta is equal to 0, right? So theta at theta is equal to 0, either you have this loop and the loop is same, okay. Now for which theta varies from, okay, that is 0 to pi by 4. So this is pi by 4. If you take here this particular line, it turns out to be minus pi by 4. So total how many loops? 1 2 3 4. So since it is symmetric about the pole, then definitely I can make use of, only I will take this particular loop and evaluate it and then multiply it by, that is 4 into my double integral, right? So of one particular loop, right, that is dx and dy. So this area I will take only with respect to only one part of the loop, okay. So here, as I said in my previous lectures also, so this was all about the Lemniscate of Bernoulli. So this is it is always given by the formula, that is r square is equal to a square cos 2 theta. Now since how to plot the graph, if you are there in the examination, so see here, this is your 0 degrees or it is 2 pi this side, okay. So so you know that this is if theta is the angle, it is revolving from 0 degrees to, and it is tracing this whole complete circle, one complete cycle, right? And this is the radial vector along with theta which moves, right? Now what I'll do is, suppose if you are taking some one complete cycle, it is 0 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4 and so on till 8 pi by 4. So this turns out to be what, 2 pi, right? This 2 pi by 4 is nothing but pi by 2, right? So as I said, if you take the graph or plot the graph for r square is equal to, and it is a square cos 2 theta, a square cos 2 theta, and if you take the value, that is if you take cos theta is equal to 0, then this turns out to be a square. So see here, value of theta is what, here it is 0, and value of r square is equal to a square, it is a. So this value is, that is, what is the radius? Radius is always a from the radius is always a point from the origin to the point on the curve. So this is my curve, this complete thing is my curve, so it is a. Now pi by 4, it is what, 45 degrees. So between 0 to pi by 4, whatever values you take, okay, it might be 10 degrees, 20 degrees, so all these points it is tracing out. Now when you take pi by 4, so theta is equal to pi by 4. So if you substitute in place of pi by 4, right, so 2 ones are and this 2s are, so pi by 2, it turns out to be cos of 90, it is 0. So value of r, it turns out to be 0. So see here how for every point over here, okay, sorry, I will take this, enlarge it for you, okay. So 0 at theta is equal to 0, if you take theta is equal to 10 degrees, 20 degrees, 30 degrees, 40 degrees, and then 45 degrees, so eventually all these points will approach towards 0. This is how it goes, right? And then pi by 2, it is negative, so here I have written so but from theta is equal to pi by 4 to pi by 2, it becomes negative, which is not possible, right? Then again if you take from pi by 2 to, that is pi, okay. So this value turns out to be, since it is symmetric about the pole, when you take its symmetric value, test it for theta, okay, so you have this particular graph, right? Okay, yes. So what we'll do is we'll move on to the next concept, sorry, not next concept. So here it turns out to be, that is 0 to pi by 4. I hope that LeMisnet once more I will give you a screenshot of that, how to, that is plotting of graph with respect to the value of theta and r, okay, fine. Now here if I am taking this particular part, either I will take, okay, so the plot which I was showing is correct almost, okay. Here it is pi, so here it is a square, which is positive, okay, and so therefore the value of here it is pi, it is a. So whatever value you take, then again from pi to, that is if you are moving till, that is 5 pi by 4, here it comes like this. So here it, all these values, that is if you take 180, 190, okay, then this is 270, then 200 degrees, all these values it will approach till 0, and at 3 pi by 2, here it is minus, and that is, it turns out to be again minus a square, which is not possible, okay. Then again from here, from 0 to, it moves on till, that is a square, right? So here the value, now sorry, not I should not take vertical and horizontal strip, because I am taking that is for this particular loop, right, only this upper loop of the first quadrant. So here it will be my theta moving from with respect to the radial vector r. So theta, how is the value of theta moving, that is, this is 0 to what, it is moving till this particular line, that is pi by 4. So theta varies from 0 to pi by 4. Now what is happening to r? R varies from, okay, it is 0, it is always a point from the origin to the given curve. So this curve equation is what, it is r square is equal to a square cos square theta. So value of r will be, that is square root of a square cos 2 theta. Therefore a square value I will take outside, so this turns out to be a square root of cos 2 theta. So the required area is 4 times double integral of dx dy. So this dx dy will always turn out to be, that is some variable b, that is the region b or area b, r dr d theta, that is Jacobian, right? Okay, now 0 to a cos square root of that is a into square root of cos 2 theta r dr d theta, and it is 4 times this is multiplied by, fine, and it is 0 to pi by 4. Now r square, now first what is this? This is in terms of what? R is equal to, and this is my theta is equal to, right? So first I will evaluate it with respect to, that is dr. So r square integration r square divided by 2 over the limit, that is 0 to, that is a square root of cos 2 theta d theta. Now this 2 if I take outside, so it turns out to be 2, right? And this after evaluating, right? So, and this is what r square it is, so this cos square theta, that square root sign and this gets cancelled, so it is cos 2 theta, and this 8 comes out, so it turns out to be, that is a square, fine. So 2a square in the bracket, so cos 2 theta integration is sin 2 theta divided by 2, and then I am integrating it with respect to theta, so it is 0 to pi by 2. Therefore a square is equal to this 2 and this 2 gets cancelled, sin pi by 2 minus sin theta. So sin pi by 2 is 1, sin it is 0, so your value turns out to be a square, fine. Okay, now see here, this is what I was okay, so let me have this question number 4. Find the area lying inside. So first thing is, you should always have the habit of reading the question properly. I need to find the area lying inside. Inside what? Inside the circle. Okay, so this is my circle, this is inside and this is outside, fine. Okay, this is how you analyze things. And the circle is r is equal to a sin theta, and outside the cardioid, okay, r is equal to a 1 minus cos theta. Okay, now at any instant if somebody is sitting in the examination and you do not know how to draw a rough sketch, so I will help you out. See here, forget about this because I have already written and I am only going to explain you. So first thing is, you take r is equal to a sin theta. So this is my equation, r is equal to a sin theta. So always have the habit of drawing a rough sketch. First thing is, you take a rough sketch. See here, for if I take the value of r, r is at a distance a times, this a might be, that is 1, 2, 3, 4, 5, 6, any particular distance, right? Okay, so r is at a distance a sin theta. Okay, so if I am taking sine, first what you do is take a value of theta, some standard angle only you take, that is 0, pi by 4 and 90 degrees. Okay, fine. So, and always you know the range and domain, that is it is -1 to 1 over here, right? And domain is the whole real line, fine. So sine of 0, so please mark it up here, it is, and that is r is equal to, that is it turns out to be 0. Then sine of pi by 2, so sine of pi by 2 is 90 degrees, so here 90 degrees, so at a distance, so it is 90 degrees is 1, but here r is equal to a, so some a here it is. So obviously this equation for taking any other values of theta, so obviously it is a circle on the upper half plane, right? So whatever value you take is from 0, then 10, 20, 30, 40, 50, 60, 70, 80, 90. Then again if you take again the values of theta, again if you increase, so again it will turn out to be a circle like this, and this is the circle on the upper half plane. So when you plot the graph for different values of theta, so this you will have this particular graph. Okay, now since many of the students were asking, sir, we are having problem in plotting the graph of cardioid, right? So first thing is you take this equation and keep in mind the equation of the cardioid. So the equation of the cardioid is there are two cardioids. One is four. One is opening up, and that is four types. So r is equal to a 1 plus cos theta, and r is equal to r into 1 plus cos theta. R is equal, that is r is equal to, sorry, so I'll take my words back. It is r is equal to a 1 minus cos theta. One more cardioid, it is r is equal to a 1 plus cos theta, and r is equal to a 1 plus or minus sin theta, right? So this plotting here I have done it for you. Okay, here see it. Forget about this. For what you do is, so first you write your equation. This is your given particular equation, right? So I want a complete, this is my first quadrant, second quadrant, third quadrant, fourth quadrant. So complete one cycle, so it will be 2 pi. So this is pi by 2 or 0 degrees, pi by 2, pi, 3 pi by 2. So what I do is I will take only the standard angles, right? So like 0, here it is 2 1 2, that is pi by 2. Here I will take pi, here I will take 3 pi by 2, that is 270 degrees. Now what I'll do is, so r is equal to, right, a, I will take only the standard angles. Okay, r is equal to 0. So cos of 0 is what? Cos, if I substitute cos of 0 here, it turns out to be 1. So 1 minus 1, it turns out to be 0. So here my value for this is 0. Now if I take cos pi by 2, so cos pi by 2 is nothing but it will turn out to be it turns out to be 0. So my value turns out to be a over here. Now this is pi. So here r is equal to make use of allied angle minus, it is cos of, this turns out to be, let me write it in a proper manner. Chalo, yes, r is equal to a, okay, 1 minus, it is cos of, again in the bracket you'll have done this 90 plus 90 degrees, right? It will give me 180 degrees, right? So which is equal to, this is I am doing for the students, those who are unaware of it. So 1 minus cos of 90 plus 90, so it is second quadrant, right? So second quadrant, it is negative, so sine, this turns out to be what? Sine of, okay, so this will turn out to be sine of 90 degrees, okay, but here it is negative, it becomes plus, right? So which is equal to, sine of 90 is what? 1. So a, this 1 and this 1, it becomes 2, and that is the reason it is 2a, right? Similarly, if you take the values for making use of allied angles, that is 3 pi by 2, 270 degrees, it is a, and for 2 pi it is 0, right? So what I'll do is, how to plot this. See, when it is 0, here you write 0, that is r value. When it is pi by 2, see, between 0 to pi by 2 there are many values of theta. It is 10 degrees, 20, 30, 40, 50 and so on. So when you take this, all this point you will find here, right? So pi by 2, it is at a distance a, some distance a, okay, and then from pi by 2 it is moving till, that is, here it is, see, this is my a, and here it is 2 times of a. So here it will obviously from pi by 2 to pi, so some other values, that is 90, 100, 120, 130, 40, 50, 60, 70, 80, all this value will trace here. So the value of r will be here. Similarly, from moving from pi to, that is 3 pi by 2, you will have eventually have the value, all this value tracing till a, this is a, okay, and then again if you take from 3 that is 270 to 360 degrees, you will have this particular value. So r minus, whenever it is minus, so this is the cardioid, okay. Similarly, if you take the values of r is equal to a 1 plus cos t theta with taking with standard angles, okay, so this will be the rough sketch of it, right? So now coming back to the problem. Yeah, So this is the cardioid, and okay, so now the common region, so when I'm plotting this, it is r is equal to a 1 minus cos theta. So if this is the rough sketch, now coming back, let us see where is my region. So inside it is, so this is the shaded region, can you see? Okay, so this is my area to be find out, because here there is no circle, here there is no circle. I don't want outside the circle, right? And inside the cardioid, outside the circle and inside the cardioid. So this will be the region if you want, if the question is given in such manner, right? So area is equal to, see here, this is obviously the value of theta is 0 to pi by 2, right? So this, only this first quadrant I am making use of. So value of theta will be this, that is 0 to pi by 2, right? Next thing is, so this is r is equal to, that is if I am taking, see how r is moving, sorry, r value is what, it is tracing these two particular values, right? Either you take this or you take, sorry, from here to here. So value of r will be what? Value of r is, see here, r is a from, okay, so this, if you take the radial vector like this, so it is tracing these two particular curves to which I want to find my that is value. So r will be, that is definitely it will be, that is r is equal to a 1 minus cos theta and a sin theta, right? So r dr by d theta, fine. Okay, therefore this is on evaluating, this will be r is equal to, and this is theta is equal to, right? So it is r square divided by 2 over the interval, that is a sin theta, and that is a 1 minus cos theta d theta. Therefore this turns out to be, that is r square, 1 by 2 I will take outside, this a square also I will take outside, this is sin square theta minus, this is 1 minus cos theta, the whole square. Now if I split this up into two integrals, that is 0 to pi by 2 sin square theta d theta minus integration of 0 to pi by 2. So this is a minus b the whole square formula, a square minus 2ab, and that is 2ab plus b square d theta, right? Then this I make use of reduction formula, I get this particular answer. Then I evaluate this one with respect to d theta. So this is theta, this is cos theta, it turns out to be sin theta. This is again, if I take the integral, that is 0 to pi by 2 cos square theta. Here my value of n is 2, that is which is even. Then again I make use of reduction formula. Therefore after evaluating I get this particular answer, right? Please be careful, here it is not r is from 0, it is from the value, that is because it is a common region shared, right? So it is a 1 minus, that is, see, upper limit minus lower limit. So r value will be this common shaded region, right? Okay, they have not asked you to take the value of r in the first quadrant, that is common region also shaded, right? Then it could have been 0. Okay, now find the area bounded between the parabola, that is y square is equal to 4 minus x and y square is equal to 4 minus 4x. Now this equation, so equation 1, and let me consider this as equation 1 and equation 2. Therefore by symmetry, so see it is symmetric about x-axis, right? So what I'll do is I will take 2 times area of first quadrant, since if I fold this paper along x-axis, so definitely it is symmetric. So why do I need to calculate the whole of the thing? I will calculate only the first quadrant. Now graph, plotting of graph, see here, y square is equal to 4ax. So y is equal to, first thing is you should draw this rough sketch, right? And then this is 4 minus x, right? So see here, if I take the value of x as 0, right, what will happen to the value of y for this particular thing, right? If I take x equal to 0, the value of y will be 2 here, right? So y square is equal to, I will take plus or minus, fine, okay. So when I'm taking the value of x as 0, so what will happen to this? So if I'm taking this 0, so it turns out to be what? Y is equal to 2, that is plus 2 and minus 2. So these are, so plus 2 and minus 2, that is for y. If I'm taking x equal to 0, so value of x is 0 over here, 0 over here, and value of x is 0 over here, right? Now since I want to avoid, and that is imaginary thing, so what is the maximum possible thing? See, if I take 5 over here, it turns out to be plus or minus I, okay. And because area is so just to avoid that thing, so what I do is, so this maximum possible value, if I am taking 4, so this y is 0, so see here, so y is 0 over here, right? So this is 4 comma 0, so this is how it goes here and here, right? So this part is over of this equation. Now coming back to this particular equation, okay, equation 2. Now if I take y square is equal to, that is 4 minus 4x, and if I take, that is y is equal to plus or minus square root of 4 minus 4x. If I take x equal to 0, what will happen to this? That is, again it will be, that is plus or minus 2, it will be this, okay, plus or minus 2. Then if I take x equal to, what value should I take? If I take x equal to 1, right? If I take x equal to 1, this turns out to be what? 0, right? So here it is this point. So obviously if you take some other values, so obviously this graph will be this particular thing, right? So since I require to take, that is only the first quadrant, fine, so all the plotting is being done with respect to its rough sketch. So I will take, the required area is 2 times area of first quadrant, integrating along horizontal strip. So what I'll do is, I will take this horizontal strip, right? So x varies from, right? So x, you need to express y in terms of x, so this particular thing, so y is square it is, right? So what I'll do is, x varies from, that is, so this curve is nothing but y square is equal to 4 minus 4x. I will express in terms of x. So what I'll do is, so x I will keep as it is, so x is equal to, that is this equation, so 4 I will take that side, okay, or else 4x I will take this side, so it becomes plus, so that is 4 minus y square is divided by 4 to this particular curve. This particular curve is nothing but y square is equal to 4 minus x, therefore x is equal to, that is y, sorry, it is 4, x is equal to, that is 4 minus y square, right? So x varies from x equal to 4 minus y square divided by 4 to 4 minus y square. And what is happening to the value of y? So y is the vertical strip, so it is, that is 0 to 2 here. Y value ranges from 0 to 2. Do not take 1 to by mistake you might take 1 to 2, because here the values here, it is 0 to 2, the maximum value. Therefore thereafter the required area is 2, and over the given limits, that is x is equal to 4 minus y square divided by 4 and 4 minus y square, 0 to 2 dx dy. So integrating it, so this turns out to be x over the limit, this particular limit dy. So upper limit is 4 minus y square minus 4 minus y square divided by 4. So simplify this, you get this particular answer. Take 2 by 4 common outside, 12 minus 3 y square dy, integrate it again, then it is 12y minus y cube over the interval 0 to 2. Simplify it, you will get an answer, that is 8, right? Okay, fine. So find the area lying inside the cardioid. So it is r is equal to a 1 plus cos theta, and r is equal to a. So this time it is a unit circle, so it is A. So R is here, it is at a distance A, here it is at a distance A, here it is at a distance A, here it is at a distance A. So this is a unit circle at a distance A, right? So R is equal to x square plus y square, you can say, right? Now so the required area is, okay, so when I draw this figure, so the required area is okay, so along theta, so by symmetry, so this rough sketch, so required area is 2 times, okay, the area along theta. Theta is 0 over here, right? So the area lying inside the cardioid, so here the area is lying inside the cardioid. So this is the, okay, area lying inside the cardioid, and outside the curve, that is R is equal to A. This is not 0, this is A. Fine, okay. So this is the cardioid, inside the cardioid and outside the cardioid, this is the common region, okay. Now required area is 2 times area above the line, because this is my first area and this is my second area, and depending upon the theta, so theta is equal to 0, this particular line, so it is symmetric over here, okay. Now theta varies from what? Theta varies from, theta is an angle, so it varies from, that is this complete thing if you are taking, so theta varies from what? That is 0 to pi by 2, okay. And so what is the curve, what is the value of the curve? Here it is A, right? So A2, what is the curve here? A1 plus cos theta. Let me check the previous, yeah. So here the value of R is ranging from what? A. See here, this is, let me take some other color today, yeah, this is the circle. So R is always the value. Now for common region here, R, this curve value is what? A. So R is at a distance A, and what is the curve over here? This is the curve of the cardioid, right? So value of R ranges from A is equal to, that is A1 plus cos theta. Similarly, you have this problem over here. See here, what was my circle here? So this is my circle, and this is the cardioid over here, right? This is curve. So value of R ranges from what? Where is, okay, so I have not written it, okay. So value of R ranges from A, this curve, to this. So how my radial vector is moving along the theta? So from this curve to this curve, right? So it is tracing all the values. So it is R is equal to A1 minus cos theta of this cardioid over A sin theta of this blue circle, right? Same is the case, okay. So here this thing, right? So how my R is varying? That is from this curve, that is R is equal to A2, that is over this particular red curve, right? A1 plus cos theta, and theta varies from 0 to pi by 2, yes, okay. Now since required area is 2 times, because I am taking this first quadrant, so if I multiply both this, so it becomes 2 times of the given integral r dr d theta, right? So the ranges are from A to A1 plus cos theta and 0 to pi by 2. So this is r square divided by 2 over the interval, this given limiting points. So upper limit, it is square, right? R square it is, so it becomes 1 plus cos theta square. Don't write 1 square cos square theta, and this A square I will take it outside. This 2, this 2 and this 2 gets cancelled, right? A square and minus 1. So this A I am taking out, okay. So this is upper limit is 1, right? So A and this A I will take it outside, so it becomes A square, right? So then evaluate it, that is A plus B the whole square formula, right? So it turns out to be 2 cos theta plus cos square theta. This minus 1 and plus 1 gets cancelled, right? So it is d theta over here, that is 2 cos theta plus cos square theta d theta. Then 2 cos theta, so 2 is constant outside, so it is cos theta is sin theta 0 to pi by 2 plus this. You make use of reduction formula. Reduction formula is given to you in the previous classes. So after evaluating, you have a square divided by 4, 8 plus pi, right? Okay, now this is find the volume of the sphere x square plus y square plus z square is equal to a square using triple integral. Okay, now what did I ask? That is sphere. I need to find what volume. I need to find the volume. Okay, since the sphere is symmetrical about 8 octants, the other day I was telling you. Okay, yeah, so required volume is 8 times the volume of first quadrant. So first quadrant, this is it. Okay, as I said earlier also, that suppose this is my sphere, and if I cut this sphere into 2, so totally how many, this is a 3-dimension figure, so one quadrant will be this part. Okay, yes. Now, so obviously for which x varies from 0 to a, this time now I am not changing it to some because in question it is given find the area, find the volume, and there it was in the previous example it was changing to change of variable from Cartesian to polar coordinate, right? So here x varies from 0 to a and y varies from, that is C here. If you have an observation, whenever it is a triple integral, suppose first, second, third, this integral will have two variables. It is dependent upon two variables. If suppose z is equal to, z depends upon two variables, that is f of x comma y, and here if you take this as y is equal to, so it depends upon only one variable, that is any given function, and then here it is the finally this particular thing is some constant, right? So here it is constant depending upon one variable, depending upon two variables, right? Okay, since I am taking only the first quadrant which is positive, so x varies from 0 to a, y varies from 0 to square root of a square minus y square. So this is a unit circle, that is x square plus y square is equal to a square, not unit circle but at a distance a, right? And this is z is equal to 0 to, okay, 0 to square root of a square minus x square minus y square. Now if I take the limiting values, find these limiting values, evaluated for dy dx, right? And I did not write dz. Here it is dz. So first thing is that is integrating z over 0 to square root of a square minus x square minus y square dy dx, right? Then this turns out to be, that is I will not include this lower limit, it is obviously understood, it is 0, so it is square root of this a square minus x square minus y square dy. Now please pay attention to this particular thing. Now this a square minus x square, I can write it as a square minus x square the whole square minus y square, since I am only integrating this integral with respect to y, right? Fine. I am only integrating this, so square root of this is some, this is constant, right? Some, that if you take this as a square minus y square, so see here you have an formula here. So this was your square root of, yeah, that is inside the bracket, it was what it was, this you considered some constant, in this you considered some c or a, this in the formula, this is a you consider, this is a square minus y square dy. Okay, so the formula is a square minus x square dx, so it is x by 2 square root of a square minus x square. Here the independent variable is x, and there in my problem, in our problem, it is y. So please make a note, don't confuse yourself, and this is the formula, standard formula given. Okay, so square root of a square minus x square plus a square divided by 2 sine inverse of x by a plus c. Since it is indefinite integral, but here it is definite integral, so I do not take plus c. Now here this is here, so it is y by 2 square root of a square minus x square minus y square plus, so this is a constant a square minus x square by 2 sine inverse of y divided by square root of a square minus x square, and this is over the limit 0 to a square minus x square. If I substitute in place of y, that is here if I take that, it turns out to be, this is square, no, this square and this square gets cancelled, so obviously it turns out to be 0. I need not calculate this value turns out to be 0 for upper limit. So here it is a square minus x square and sine inverse of, if I substitute this over here, so this turns out to be 1. Sine inverse of 1 is pi by 2 minus, here it is 0, here it is 0, so this is upper limit and this is minus lower limit, and with respect to dx, right? And then after evaluating I get that is 2 pi, I take it common outside, that is pi by 2, okay, and then it becomes 2 pi over the limit 0 to a, that is a square minus x square dx, which is equal to 2 pi, that is a square x minus x cube. Then after evaluating you get this particular answer, okay. And it's not the end, and this is maximum problems have been solved, right? And this will be few more extra problems you can discuss with your mentors. 2-3 problems I have not done, which I have given it for the homework, and see that you people study. At any instant I am telling you again that you do not understand the concept, please let me know, or contact your mentors, they will help you out to the fullest. Take care of yourself. Thank you very much.